In this video, we will try to understand what do we mean by domain and range, and why are we asked these questions that, find the domain for a particular function and find the range for a particular function. So see, domain, we understand what a function is by now. So a function is a relation, it's a rule defined by what property? That for each input value, there is a unique output value. So for each x belonging to, we can say the domain, if you're calling it domain D, I'm going to put more thrust on what this domain D is. Domain D, there is a unique y belonging to the codomain, I would say, such that f of x is equal to y. So for each domain value, you need to have a unique output. Now, so what is domain? Domain is the set of input values. Domain is the set of input, the input set. Now, for each x in domain, you need to have a unique element in the codomain. So that means you cannot have any idle element in the domain. Idle, that means an element for which you don't have an image. So domain set is essentially the set of, we can call them pre-images. That is those x which will lead to an image, which will have an image, okay? So domain is the set of all pre-images. It's the set of all x for which the function is defined. Or in other words, set of all x's for which the function or the algebraic expression, the functional notation, the function is defined. It's defined, it's well defined. So the function needs to be defined for all those x's. So this is the kind of scenario that you have. It's a relation f that you have from here. Say this is your input set, this is your output set. So in this scenario, we denote it as f from A to B. Your x's are somewhere here. You'll find your fx's somewhere here. What we are saying is that for each x that you have in this set A, you need to have some images out here. So you cannot have idle element here. You cannot have any idle element here. Let me tell you what we are actually talking about by looking at certain examples. So suppose fx is 1 upon x minus 1. What is the domain for this function? Now clearly, can you see something here? That your denominator consists of x minus 1. Now the moment your denominator is 0, the number is not defined. And we want the function to be defined for all x. So what is that x for which this formula or this functional notation is not defined? For x equal to 1. So what will we say? X should not be equal to 1. So what will we say about the domain? The domain for this function is all real numbers. No other real number is a bad x except for 1. So 1 is your bad x. So that's what I say every time, when we are doing domain. So you have to actually figure out what are your bad x's and take them out, essentially, because for those x's, the formula would not be valid. The expression would not be valid. The function would not be valid, okay? So just take out 1. So x should not be equal to 1 because when x is equal to 1, because x equal to 1, then x minus 1 is equal to 0. So denominator should not be 0. This is sort of a domain restriction that you have. So a very common domain restriction, you can say denominator should not be equal to 0. And that's what we've applied here, okay? Now, let me talk about another example out here. So, suppose you have to find out the domain of square root of 1 upon x minus 1. So, earlier we were talking about 1 upon x minus 1. Now, we're talking about 1 upon x minus 1. Now, it's a square root of this. Square root of 1 upon x minus 1. So, what will be the domain? What are the good x's and what are the bad x's? Let's just find it out. So, whatever is inside an even root, you cannot take even root of any negative number, right? So, whatever is your input inside square root, fourth root, sixth root, that is even root. Whatever is inside should be greater than or equal to 0. That means 1 upon x minus 1 should be greater than or equal to 0. So, 1 upon x minus 1 is greater than or equal to 0. That what kind of x's will satisfy this? That's what you have to figure out. So, what kind of x's will satisfy this? For this, x minus 1 will have to be greater than or equal to 0. Or in other words, x will have to be greater than or equal to 1. Because see, 1 is, this is, if you want to understand the logic behind it, you have 1 upon x minus 1. So, 1 is any which way is greater than 0. So, that means x minus 1 should be actually strictly greater than 0. Let me now include another thing out here. Now, here I must have strictly greater. Why? Because the denominator should not be equal to 0. So, moreover, x minus 1 should be strictly greater than 0. So, 1 is strictly greater than 0. X minus 1 should be strictly greater than 0 for this expression to be positive. Because x minus 1 cannot be equal to 0, because at 0, when the denominator is 0, this expression inside the square root will not be a valid expression. So, you cannot take square root of that, right? So, that is why x minus 1 should be strictly greater than 0. So, that means x should be this time strictly greater than 1. So, that means an open interval, you will call it open interval. You cannot include 1. That's why. Everything greater than 1 is good, but 1 cannot be included. So, 1 to infinity. Everything from 1 to infinity is good. Except for these, I cannot take any other input. For example, what if you take something lesser than 1? Just an example for you to think. What if you take x equal to 0? If you take x equal to 0, you will have square root of minus 1, which is not valid as an expression, right? So, you cannot take square root of minus 1. So, that is why the domain should be from 1 to infinity, not including 1, and that is why we have open interval symbol here, okay? This is what is an open interval symbol, or you can also quote it as this, 1 to infinity. Okay? It's one and the same thing. Now, I'm going to talk about range, and let's understand what range is. I have used this word range. So, please understand, when it's written that the function is from A to B, this A is domain from where you are taking your input, but here also you have certain restrictions. So, you will have to find out the natural domain for any given function. And B is the supporting set. It's the codomain. So, then what is this word that you have here, range? What do you mean by range? Range, as the name suggests, range of f, to be more precise. So, what is the range of f means? What all functional values can be derived by this formula or this function f. Range, the smallest value to the biggest value of f that you can take. That's what is range of f. Or in other words, it's a set of all possible outcomes, all possible output that you can have. So, it's a set of outputs. So, the set of all values of fx that the function assumes or derives is called range. Is called the range. So, it is basically the set of all fx's where x's are coming from the domain. It's a set of all fx's where x's are coming from the domain, okay? It's a set of all images. In other words, set of all images. In other words, it's a set of all images, we can say. So, your domain is the set of all pre-images and range is the set of all images. So, again, let's now pick up the same function that I had given to you, square root of 1 upon x minus 1. So, what is the range for this? If we want to find out the range, we know the domain is open 1 to infinity. So, everything strictly greater than 1 is part of the domain. What will be the range? Now, for range, can you see something very peculiar about this function? And that is, it's a square root function. Whatever comes out of a square root is actually positive. Whatever comes out of the square root. So, y is equal to square root of 1 upon x minus 1. So, whatever will come out is actually positive. It's actually, greater than or equal to 0. It's greater than or equal to 0. So, can we be more specific? Let's see that. Can you attain 0 here? Can you attain 0 here? Your domain is 1 to infinity. So, you will always have 1 point something here. Here, attaining 0 is not possible. You cannot attain 0. Attaining 0 means x is tending towards infinity but never reaching it. So, it is never reaching 0. So, it cannot be actually equal to 0. So, it will be strictly greater than 0. You start with any input a little more than 1. You will always fetch a positive value, but it will not be 0. It will be 0 only at infinity. When x is equal to 1, when x is equal to 1, what do you get? You actually, at that time, you get infinity. When x is tending towards infinity, then you actually get, the functional value y tending towards 0. So, this will be strictly greater than 0. So, if somebody asks you, what is the range for this function? Clearly, by looking at the input, you can say that it will be strictly greater than 0. By the logic of square root, you can say that it will be greater than or equal to 0. But we know that equal to 0 is not possible with this expression. So, that means it has to be strictly greater than 0. Be careful with these kind of things. Now, next question, I wish to find out the range for x minus 1 upon minus x plus 3. So, let's work with this. So, if you have this sort of an expression and you wish to find out what are the values of outputs that you can have, what fx's can you have? There's a simple way of figuring it out. What do? You try to find out x in terms of y and find out the conditions on y. So, that's what we will do here. So, let me just cross multiply. So, y into minus x plus 3 is equal to x minus 1, and that implies that I have minus xy plus 3y minus x plus 1 equals to 0. Or in other words, I have, I'm going to just collect x. So, I have minus x y plus 1 is equal to minus of 3y minus 1, or in other words, I have x is equal to 3y plus 1 whole thing upon y plus 1. So, clearly what I can see is that when y would be equal to minus 1, your denominator will be equal to 0. That means x will become infinity, right? So, what you get from here, you realize that y plus 1 should not be equal to 0. That implies y should not be equal to minus 1. So, what is your bad y, or which is that y that you cannot attain? Or in other words, there is no x in the domain such that y could be equal to minus 1. You cannot have any x in the domain because the x that you are actually fetching when y is equal to -1 is infinity, and infinity is not a finite number that you can fetch, right? So there is no x in the domain which can lead to fx equal to -1. So therefore we will say that the range of this function, all other real numbers are good. I'm not getting any issue with any other real number except for -1.